Hello, my name is Daniel Oyok and I'll be taking you through the introduction to machine learning operations for explainable machine vision techniques for fish disease detection, which is our term project. I'll start by defining what machine learning operations, and these are basically practices and tools and workflows aimed at operationalizing and scaling machine learning modules effectively. And the relevances of MLOps in our project are that MLOps they ensure accuracy, and which helps help to maintain and improve accuracy of the developed module for better decision making, like detecting the fish diseases, and this is done by continuously monitoring the performance of the module. And the other is interpretability. Well, um, MLOps help us to explain the predictions that were made by the module to the stakeholder, which are basically maybe the clients. And also machine learning operations ensure reliability, as in these practices enhance reliability of the entire machine vision system, and this by ensuring consistent performance of the module, and also um, consistent operation of the module, and also being robust to varying conditions, among others. Well, the MLOps trends and techniques influence in our project are that model interpretability techniques. These techniques help to understand the factors influencing the model's prediction, like to the particular stakeholders, to get to know how did the model come about with this result. And and the other is versioning and reproducibility, which ensures that the deployed module for the fish disease detection can be tracked back to their development stages, promoting transparency and accountability. Well, the other is CI/CD, which is the continuous integration and continuous deployment, which ensures that the model stays relevant and effective in detecting emerging diseases or changing environments. And lastly, this technique is a model training, model monitoring and maintenance, which ensures continued reliability of the fish detection modules by identifying issues and corrective actions, such as retraining a model or updating features to maintain its optimal performance. And the application of DevOps and DataOps in our project is one that DevOps are applied in three different aspects: the model development, model deployment and monitoring, and feedback loop and iteration. And this is how it does it. For model development, DevOps principles are applied throughout the model development process, and these include version control, collaboration, and automation practices, which ensure the development process is very well streamlined. And for model deployment and monitoring, this is another uh, crucial stage for deploying a machine learning module into production environment, if by doing which ensures efficiency and reliability. And the other is feedback loop and iteration, which facilitates this technique facilitates the implementation of feedback loops between the development operations and the end users. And this includes collecting feedback uh, from various stages of the deployment process. And lastly, that application of DataOps in our project would be that DataOps are very crucial when it comes to data collection and preprocessing, which is a principle applied to streamline the process of collecting and preprocessing data for training the learning module. And um, this involves automating data collection and ensuring data quality. Lastly, feedback and loop iteration. This enables DataOps enables to establish the feedback loop for data quality monitoring and model performance evaluation. The difference between heavy and light MLOps in our project. First of all, heavy MLOps These involve comprehensive and sophisticated processes and tools to support the machine learning pipeline. And while for the light MLOps, these are more simpler and more streamlined approaches suitable for smaller projects and those with fewer resources. And for heavy MLOps, this involves infrastructure setup, automation and orchestration, model training and experimentation, the CI/CD, model training and maintenance, scalability and performance optimization, security and compliance. Whereas for light MLOps, these involve simple infrastructure setups, basic automation, limited experimentation, and simplified CI/CD, basic monitoring and maintenance, scalability consideration, and simplicity and ease of use. For integration of MLOps hierarchy of needs and maturity modules, for MLOps hierarchy of needs, we look at data, how we're able to get data for our project, the module, how we're able to develop our module so that it's able to detect the fish disease, and the processes like the steps we go through during the development stages, whereby maybe we have to monitor and also test and validate our module. The monitoring process, which is a continuous one, so that we ensure reliability of our module. And for the governments, we'll be trying to ensure that our module doesn't violate any of the security outlines. And for MLOps maturity module, we focus on there are several stages: the initial stage, managed stage, defined stage, quantitatively managed stage, and optimizing stage. For strategies to handle data poisoning, data drift, and operationalizing microservices. Data poisoning, here we look at data quality assurance, which by implementing rigorous data quality checks and validation process to detect and mitigate anomalies. And for robust model training, these are techniques, we use techniques as adversarial training or use of outlier detection to make modules more resilient to poison data. And for also regular monitoring the inputs and model output for any sign of anomalies or unexpected behavior of the module. For data drift, we will look at monitor. We use monitoring and detection. We set up systems to continuously keep track of the data and data distribution changes over time, and detect drift by comparing current distribution with those observed during the model training. The revalidation and retraining establish processes to periodically revalidate models and retrain them using updated data to ensure effectiveness. And for feature engineering, develop adaptive feature engineering techniques that can automatically adjust to changes in data distribution. And for operational microservices, we to use containerization, which is a technology which uses technology such as Docker to package microservices along with their dependents, enabling consistent deployment of our module across different platforms. And for service orchestration, we use tools like Kubernetes to manage and scale microservices efficiently, ensuring high availability and fault tolerance. For API design for interpretability, we design microservices with clear and well-documented APIs to facilitate integration with other systems. And for monitoring and logging, we implement comprehensive monitoring and logging mechanism to track performance and resource utilization and health microservices in real time. The deployment pipeline establishes automated deployment pipelines to streamline the deployment process of the microservices, enabling rapid and reliable updates while minimizing downtime. The role of continuous integration and continuous delivery and feature stores. The CI, the continuous integration, ensures that changes to the machine learning module code base are regularly integrated and tested. And for continuous delivery, this ensures that the validated machine learning modules are deployed rapidly and reliably. The feature stores, They store pre-computed features derived from raw sources, making them easily accessible for model training and inferences. And importance of specific files in the Python project. For example, the readme.tmd file. This provides essential information about the project, and the requirements.txt file lists all dependents required to run the project. And for data directory, this contains data sets for training, validating, and testing our module. The src source file directory. This provides an housing for our source code of the project, including Python scripts and modules. And for the modules directory, it stores the trained module, learning module, and associated metadata. And the docs directory, this contains documentation for the project and explaining the key concepts of the project.